Hello, and this is now lecture 12 of agricultural electrification. We are just after the topic of safety, well, extending to this topic on wiring or wires, because we are still interested with the insulation of wires. First, we want to effectively deliver the electricity through the wires, okay, because that is how it is, and unless we now find a way to deliver electricity by air. But until then, we still have to get to know the uh, wire, okay, the type of wires available, and because we are most importantly interested also with safety, the insulation involved in this wiring, okay. There are many different applications and uses for these different kinds of wires, and so we have to go through them in this discussion. Primarily in the engineering discipline, we want to make sure that we are using the right amount of or the right kind of wire because we want to save on resources. Okay, we may over design, but in most cases that would entail a lot of costs. Okay, so our concern here is to identify the right type of wire and also the needed insulation for the applications because they are indeed critical to the operation of a specific activity on the farm or the agricultural facility. Okay, lecture 12. Now, here are different kinds of wires and cables. Okay, a wire is different from a cable, but I'll leave you to that and differentiate between the two. But we're going to talk about wires, and usually wires are usually single cylindrical flexible strand or rod of metal that are acting as conductors. And we have already discussed a lot of the materials that are good conductors, TC lecture 3. And we have also then discussed the varying sizes and insulations depending on the use of the wire, okay? And we'll go through them in detail here, okay? Because we will know the different uses and applications of this wire conductors and their insulation. Now, the insulation is a non-conductive material, okay, and it's restricting the free movement and flow of electrons in the conductors. Why? Because basically you want to limit the loss and also keep people and other living things safe from the current or from the electricity. And it is trying to do the non-conductivity, okay, the insulation by the influence of, it allows a little current flow and with a little electrical field, okay. So it doesn't necessarily mean that the magnetic field is eliminated because we know electricity has an electromagnetic structure or form, okay. Now in figure 1, okay, these are many types of wires, okay, for uses and applications that are varied, okay. And a certain wire would be best suited unless they have been improved on or already phased out or something like that. Now we now go to the main types of wires, which are solid and stranded types. And we just know that we have the solid as something too difficult to bend, and because as they get bigger in size, they become bulkier to work on. So the stranded wire is a development because it allows twisting, easy twisting, okay, of the same, even if the same effective area as the solid wire. Okay, so this is a bendability property of the stranded wire. Again, when we say that they have the same effective area, they are carrying the same amount of power and electricity, okay, same voltage and current in the area in along the conductor. And it does gives us the amount of current, okay, when you're talking about the effective area, it gives us the amount of current flowing through, okay, and the bigger the wire, the larger the ampere rating of such wire. Now we have table 1 showing us the metric in American wire gauge or AWG classification, okay. We have the metric as the official in the Philippines, but we can also make use of the AWG, which is also available in the market, and it's the um, well, it's actually following the imperial system, and we have the ampere rating again. Okay, just to show you what's ampere rating is the current rating that it is allows to flow, and it's the very critical figure in sizing up a wire. Okay, your wire. When you say a 5 ampere rating, okay, when you let 7 ampere uh, electricity flow through that 5 ampere rating, the wire may burn, okay, because it's actually the well the wire can carry it, it may, but the insulation, it would burn through that uh, ampere rating, okay. Also, it may burn the wire or may melt the wire. It's something like that, okay. So this is just a continuation of those classifications. The higher the wire diameter, if you could see from the metric size in meters and millimeters squared, as you go bigger in millimeter size, you get the ampere rating bigger in value also. So that would mean that entail more cost to the um, in the electrification of a system. Okay, that will mean more costs. So when you see in the market an AWG of 18 using this table, you would easily know that the ampere rating would be 7. Later we'll see the different applications of this wire sizes depending on the wire size, but as well the uses of the different um, wire combinations of with the different insulations, because it would just be varying with the size and the insulation. Okay, we have the AW measurements again, still going up to 107 millimeters squared. It's now carrying 230 amperes. That's a very big value now for amperage. Okay, the most common gauge sizes that we'll be using in ABE structures and buildings are shown. We have the 18 gauge, 16 gauge. I'm referring to the EWG, okay? And the 14, 12, 10, 6, and 2. It's not given there, okay? So you have the 10 ampere low voltage lighting and lamp cords for 18 gauge, okay? 16 gauge is for 13 ampere light gauge, light duty extension cords. Okay, 14 gauge is 15 ampere light fixtures, lamps, lighting circuits. Okay. And so on. Okay. 12 gauge is kitchen, bathroom, auto receptacles, and 20 ampere 120 volt air conditioners. Okay. 10 gauge, 30 ampere. Okay. So The smaller the EWG, okay, the bigger the diameter, but the bigger also the ampere rating. So for 4 gauge, you already have their 60 ampere electric furnaces and large heaters, probably boilers, okay? But 6 gauge, those are for cooking ranges, okay, which are very high powered, okay? If you multiply 40 amperes times 220 volts, how much is that? Okay, it's around 10 kilowatts already of power in one. It's a lot of energy burning, okay? So individually insulated wires typically are used for insulation inside of conduit or flexible metal cable. The coding system, we have this alphabet coding system, and it relates to the performance characteristics of the wire insulation. Okay, the most common types of wire used in residential are THHN, and here's what letters mean. Okay, we have H for heat resistant, and this is up to 194 degrees Celsius. That's HH. Okay, but H is up to 167. Okay, we have W, that's moisture resistant and suitable for damp and wet environments, and we have N for nylon coated, resisting damage from oil and gasoline. We have also non-metallic cable labels. We have the NMB, standard non-metallic cable, suitable for indoor use in dry locations. We have NM, the earlier standard of the NMB. Okay, and it has a lower temp rating. We have the UF or underground feeder cable for outdoor exposure and direct burial, and SE or service entrance cable or auto-rated cable for above ground use. And lastly, we have underground service entrance cable and SE cable. This is just actually the SE, but rated for direct burial. Now, we go to the different types of insulation. And if you could see, these are all plastics. You have PVC. Okay, later we'll know the different terms for this. But well, the very essence why these are plastics, because they are polymeric and they are good insulation to protect the equipment and the user. So we have here the different types showing their different properties. Okay, with the classification rating defined as below. We have P for poor, F for fair, G for good, E for excellent, and O for outstanding. And we could see the chart labeling the different kinds of plastics as to their properties in oxidation resistance, heat resistance, oil resistance, low temperature flexibility, solar light resistance, ozone resistance. Okay, that is for O3. We have abrasion resistance, electrical properties, flame resistance, and water resistance. Okay, so we just have to look at the different applications for use. If it would have to be in open light and under the heat of the sun, so better to have something that has good solar light resistance. So you better look at this one, and you could see that FEP Teflon is better or best. We have also the PTFE and the Kinar. Okay. Now, so that's how to look at this table. Now the different, there are actually different other new developments in the field of the polymer industry, but that would have to be, I mean, this is the very basic that we would need to know. And lastly, here are the different plastic nomenclature. So we have PVC for polyvinyl chloride. We have the seven categories of plastics, but that is not used here. So we just have to go directly to the name of the plastic that is commercially available. We have LDPE, CPE for cellular polyethylene. We have HDPE, very common. That's also a generic plastic category. We have also PP, also a generic plastic category. That is polypropylene. And we have polyurethane, PUR. I think that's even just PU. But anyway, it's what's here. So we have also CPE, fluorinated polyethylene, Teflon, okay, fluorinated ethylene propylene, okay, Teflon, okay, ETFE for ethylene tetrafluoroethylene, ethylene, and PTFE polytetrafluoroethylene. Now, that's all for the wiring, okay, and I'll see you in the next lecture for our next topic of the course. Thank you for listening.